All right. So hopefully you guys are at this point or really close to this point. As far as the timeline goes, seniors, your last class is technically the 21st, but my Chantilly seniors, I will not see you probably that week because most of you are asynchronous for SOL testing. If you're a feeder student, you can come to class normal. We'll still be having class. For you guys that are Chantilly students, that whole week, you guys are asynchronous. If you want to come to class, I'll be here. You can either participate in person or virtually. If you choose to, you don't have to. So that means I know 99% of you will say, oh, I'm sleeping in. But if you feel you need to come to class to get support, I will be here because we have students in the building that are from the other schools, and so I have to be here anyways. As far as grades go, since the last day for seniors is supposed to be the 21st, then you should have all your work in by the 21st. For my non-seniors, there are so many different deadlines based on schools and exam schedules and graduation and testing and all that other stuff I can't keep. I'm going to say if you can get everything in by the 21st, that'd be great. That way I can get it graded. If the last day I think that's really they're expecting me to be kind of punching in grades for you guys is the 25th. So try to have stuff done by the absolute last day of the May 25th, which that day doesn't really make sense to me because you have another 2 weeks before school ends, but whatever. That way I'm done early, I guess, as far as grades go. So 25th to try and get everything in best you can. All right, so you guys should have put your robot arm together. I've shared this document with you. It's now called Robot Demo Add-on. It should show up in your shared files and Onshape. You cannot do anything to it but view it. So we had adjusted your arm. You had all the gearing right. Don't worry that the gears don't spin. What I wanted to show you today is how to modify the wrist to do something that might be beneficial to you, whether it's drawing on a piece of paper with a pen, or maybe, which sounds really crazy, using cutting something out with an X-Acto knife. That'd be pretty fancy. Picking up and moving checkers or chess pieces could easily be done. There's all kinds of stuff. The goal is, in the end, for you guys to write a program that's repeatable, that your arm kind of does something useful. Whether it's write your name in really big, ugly letters, or maybe move some pieces around on a small chessboard, or stack things. It's just to show that you kind of came up with something functional for your arm to do. I did give you a 10-tooth gear that will fit on this servo head in real life. And so when you come to pick up your supplies, I will print you and put in your baggie a 3D printed 10-tooth gear that fits on your servo, along with a gear rack that we just laser cut if you want it. So let me quickly put these on my servo. So Revolute, zoom in here, grab the gear, zoom out, grab the face of the servo. Let's flip that around. All right, that's not what it was supposed to have done. Flip back around the other way. What happened here? Oh, it grabbed the other side of the handle, I think. So I'm just going to use an offset to fix this. Well, let's actually try grabbing it again. I don't want to do it wrong. Oh, I see. My servo. I thought this gear was. I didn't realize this gear was hollow. That's my bad then. The real one has an end cap on it. I don't know why I made this gear without an end cap. Come on, click. There we go. That's why it did it wrong in the assembly. I didn't realize that. All right, so offset. think it's about 4 millimeters. Yep. That's just about perfect. So that's what your gear will look like on your servo. Ignore this part, it looks real. Now when placing the gear rack, you can't really place the gear rack teeth within the gear teeth because Onshape's not meant to do that. It can't handle, the math on that would be outrageous. So what we're going to do is we're going to use a bunch of flat surfaces and offset it the right distance so it's kind of in the right position. That allows us to go on from there. So we can do that using planar mates, and it takes a few to get it right. For example, we want to do a planar mate between this face here and the side of the gear rack. And it really doesn't matter where your little handle shows up, because the fact that it's planar means it can move around all in that plane area. And the only thing that matters is really how far off the plane the rack is. So for example, if I give it an offset, I want to offset it, let's do 0.5 inches and see where it's at. Oh, wrong way. That looks pretty good. So the goal is to kind of put the gear rack in the middle of the gear approximately, okay? So we say okay with that. The problem though is the fact that it's a planar mate, you can kind of move it still on this planar surface side to side. It just doesn't move very fast in this window. So now we need to make it so that it's the right engagement in the gear teeth. So I'm going to kind of move it to the approximate right location. Back just a tiny bit. There we go. So you want a very small gap between the end of your gear tooth and the flat part of the gear. That looks like it'll work out okay. And then we're going to take a measurement from the flat edge of here, the back of the gear rack, to the flat edge of your wrist. And it is a parallel distance of 0.408. So we can kind of see if we roll over it, it shows up. So that's approximately what we want our offset to be. That way it saves you a little bit of math trying to figure that out. So now I'm going to do another planar mate on those two surfaces. So back to the gear rack. Darn, it's not clicking this morning. There, now it turned yellow. And the flat surface on the edge of the wrist. All right, and we said it was going to be an offset. And now it looked like it put the two on top of each other. So remember to say solve, so it can plug that offset in comparison with the other one over here. So it jumps it back out. And then we said we wanted it to be 0.0408. Probably 0.4 would be just fine, but whatever. Oh, wrong way. Let's go negative. Remember, tab confirms. What did it just do? Where did it put it? Yeah, it looks like it. Oh, I got to click solve again. That's right. Always click solve every time you punch in a number when you're doing these assemblies. There, that looks about right. So now it only has 2 degrees of freedom. It can only go up and down. So I can click grab it and drag it up and down. See, there you go. Because we applied 2 planar mates, we can only move it in one direction. And so now we can simulate it going up and down as the gear spins. Onshape can make this move a certain distance based on how much your gear spins, but using the rack and pinion relation, but I'm not going to get into that. If you want to play with that, by all means, you could do that. All I wanted to do is see that kind of where I ended up. So now I have these two set up right. Now I want to bring in a pencil edge root to attach to my gear rack. So insert. Let me go find the pencil I made. It was in the base part studio. No, I don't want the whole base. I'll just have to delete it out, I think. There we go. Oh, it looks like it did it twice because I clicked too many times. All right, still did. How many pencils did I put in this thing? All right, there we go. So now I have my pencil. And I can just, oops, it looks like it did insert an extra base. Let me get that out of here too. Hold on, I just lost video. Ah. Let's not turn that on. All right, I think I'm back now, guys. Sorry, Blackboard is Blackboard. Kicked everybody out. All right, so it looks like you guys are all with me, and I think you guys can still see me. Let me know if you can't. So now I can attach my pencil to the gear rack. All right, thanks, Nate. And we can do that a number of ways. Really, just we want to do a fasten mate's fine. It might give me a hard time because I'm trying to do this on the cylindrical shape, and I don't gonna like that. So I will have to do. I should have made my pencil hexagon shaped, and then it would have been really easy to attach versus a cylinder. So I can do as a tangent mate since it's cylindrical. Round part of the pencil with the flat back edge of the gear. And then I can, yeah, next time you guys do this, definitely modify your pencil and make it have some sort of grooves or something on it so it's easy to align. Let's see if I can, now that I've got that done, I need to rotate it. Let's try a planar mate with the, give me something flat here. Well, I was looking for, yeah, that you might be right on that. King's Pride, that. Flat top of the eraser to the flat of that. That'll work. Solve, let's see where we are. All right, it's gotten better. And if we wanted to, we could go ahead and put in some sort of offset to kind of scoot the pencil up a little bit. Maybe, let's go backwards. There you go. Now when our gear goes up, it'll move the pencil up a little bit. And I got one more mate I need to apply. And that's just kind of scoot the pencil over so it's in the center of the gear rack. Attaching round things to flat things is kind of complicated, so I should have told you guys not to do that. Can I turn on? Let me try this. The trick would be to go into the pencil and turn on a flat plane so it shows up, but I didn't want to go into another drawing. That might work. Let me try this. All right, that kind of put the gear inside itself. And I can't go, never mind. I don't want to do that. Let's try. Yeah, this might work. I can do a fasten mate and then give it an offset. That's what I should have done earlier. So I want an X offset of that looks like it'll work. 0.2. I said a Z offset of 1. -1 now. And if you get confused when it's negative versus positive, it all depends on which surface you click first and which surface you click second. All right, that's kind of what I wanted. There we go. So what I've basically been able to do now is attach the gear to the pencil. So if you guys are trying to do something like this, make your pencil a hexagon or an octagon or whatever shape it is, and it'll work much easier. So now we can go up and down with the pencil. But we need, one, a hole through our part so that the pencil and gear rack fit through it, and some sort of sleeve, I suspect, for the pencil to be able to ride in and out of so it moves smoothly. So that gave you room to work with on the top of the top of this lower arm and the wrist, so that if you needed to, you could attach things to it to help you with that. So, for example, if we need to make a new 3D printed part that's going to kind of hold our pencil here, we can do that in this context. So, for example, and if we need to cut a hole in this for the pencil, we can do that as well. I'll do the hole first. That's the easier one. So, for example, if you want to do that, you right-click on the part you want to mess with, and you're going to say, edit in context. And so now you can kind of see an outline of the part with the other stuff around it. And so what we can do is we can right-click on this surface, put a sketch, and then project kind of how my pencil fits on that sketch. Let's go grab the top cylindrical part of it. Oh, I didn't click. Must not be clicking where I want the sketch at. All right, let's see. There we go. So I can click on the different parts. Basically, I just click the sides of the gear rack. And use project to kind of see where the outline falls on that part. And so you can kind of see how that works. Now what I want to do is make my opening bigger than that shape. So I'm just going to draw in that shape now, as I normally would, by creating a new circle, a little bit larger than the diameter of my pencil, maybe by I want like half a millimeter on each side, so maybe, so we can do 0.5 mm. Oops. Let's see where that gets us. That looks about right. That looks good. Because you don't want the pencil rub against the piece. And then we're just going to draw a rectangle that kind of represents this area here. And I really don't care that this rectangle is a little bit bigger than my gear. I don't want my gear to catch on or anything. So I'm just going to make it kind of symmetrical about the gear using coincident. And that gap there is good. That looks like a millimeter at least. So I can live with that. So now what we can do is we can say extrude. Get rid of what I want to extrude. Remove. And basically just click all the parts I want to remove. Do a cut. Is that everything? Looks like I click something, but it really doesn't matter if that little piece is there in the middle. We can just delete it later. Oh, the face of these up here are throwing me off. I didn't mean to click those. Let's click those. And now if you need to, when you have all these parts here, if they're getting in your way, you still have your menu over here if you need to go turn things off later. I can't do it right now because I'm in the middle of an extrusion. But if I needed to, I could. Let me do that real quick. Now that I'm done with my pencil, I could go back to my assembly and hide it, and then come back to the context if I needed to do that. Oops, wrong thing. Oh wait, where I thought I clicked extrude. I guess I did not. With all the other stuff in the way, it does get difficult to kind of click what you need to click. Let me just go back and do it. All right, now that I'm done, I can turn this stuff off. Let me hide these real quick. That'll make it much easier for me to do this. All right, and now if I want to go back to that context again, if I right-click on that part and say edit in context again, it'll give me my context I was currently working on, new context. We want to go back to the original context we were working on. No, it left the pencil there. I'm kind of surprised it did that. Oh, because I said old. That's my fault. Oh, well. So just rotate around to kind of get the parts you want to get to. I think that'll give me enough. So I want to do remove. Depth of 1 inch is fine. Basically, we just want a cavity there. And even if you have mistakes like this in there, I don't care. You can see that it now exists as its own separate piece, still called lower arm, and I can turn that off. Because that's basically what you want. You want the cavity to exist. And now I'm going to say go back to assembly. And now I can see there's a hole there. And I'll turn my pencil and gear rack back on. And so that's the part I really wanted to show you was if you bring in a new part, you can edit something in context to modify that part. So the next thing I was going to show you is how to make a sleeve that your pencil would fit through. And I'm going to do that so that it kind of fits on this surface here. Trying to figure out what's going to be the best way to go about doing that. I guess the easier method would actually be just put a sketch on here. Let's see, I want. So we can say edit in context. We're going to make a new context this time. Hold on, before we do that, let's do a measurement real quick. So if I'm going to make a sleeve that this pencil rides in and out of, but I want to measure how far up to the gear it is. So I want to measure from the flat surface here to the bottom of my gear. It says it's a parallel distance of 0.429. Which allows me to know that if my piece sticks up above 0.429, it might collide with my gear. So I can deal with that. I just need to know about that. All right. So editing context, new context. So now I'm going to create a new piece, make a new sketch on here. I'm going to use the same window I made already. Then I'm going to draw a rectangle that is bigger than my window. Basically a sleeve for the pencil to ride in. And I want to make sure my rectangle doesn't intersect the wrist unless you're going to bolt it to the wrist. I'm just going to like attach it to the top of my arm here, and I can glue it if I need to. Or you could put screw holes, and I can show you how to do that in just a minute. Let's see. Bring this over a tiny bit to there. Actually, I got to be careful because it's going to run into all this gear stuff here. So I want to leave a little bit of gap. All right. And I can drag that side kind of to there. If you want, you can go over the edge. In fact, that'll help me secure it. I'm going to do that. Can't you tell I'm making this up as I go along? I did not demo this ahead of time, so. So now I'm going to extrude. I'm going to click my parts to extrude. Let's try it again. There it goes. Now it's clicking. I want to say new. Let me rezoom this in a little bit so you can kind of see what I'm doing here. And I don't want to go up that high. I want to go up about, maybe about to the middle of the gear. That looks like it'll be enough room for the pencil to slide in and out of this. And so I can say, okay. And now I've got a new part that we're going to rename pencil sleeve. Now to deal with where this part might intersect the gear, I'm just going to put a sketch on it. Draw where it might intersect my servo or gear or anything else. And remove it. So now I can see that it kind of won't intersect anything except for the screw, and I don't care about that screw because I know it's actually not going to be there. It's not that big. It just is that big because Onshape made it that big. What I can do is I can use the previous sketch I had and extrude this little down as a way to help me hold on to the part right. That was in sketch 3, so let me turn that back on. Extrude just this little corner. And I want to go down. Oh, let's go the other way. I want to say, and it's turning red because it doesn't know what it wants me to add it to. So you need to say merge scope. You want to click the part you want to merge it to. You want to make sure you click the pencil sleeve and not the lower arm. So if I do that and say OK, you can see now I have this sleeve piece that I'll be able to kind of glue on or screw on to my part. And if I wanted to make it so that I could screw it on, I can just put a new sketch on the bottom of my arm. And draw a circle that's 1/16 in diameter. And I'm going to put it about a little bit away from each edge, but not so much the head of the screw is going to intersect the circle. Since I didn't dimension it, I'll be able to go back and fix it later if I need to. Now I can say extrude, click the circle, and we want to do a remove. And I'll make it a depth of 0.5. It doesn't need to be very deep. And when you say merge scope, we're going to do lower arm and sleeve, because that way it'll put a hole through the sleeve and the lower arm at the same time. I say OK. And now I can see I've got my sleeve where the pencil will ride in and out of. If I right click on it over here, I can say, go back to my assembly before I can do this. So now that I've kind of got it done, I can say go to assembly. Oh, where to go? Oh, it's still in context. I forgot to save it as a new. All right, let's go back to that. It should show up in your drawing of this piece. So let's go find the lower arm. Yeah, there it is. Because this part exists in that part, it just shows up here. Now we have to use insert to bring it back in if we want to put it in the assembly file. So let's go back to final robot assembly. Insert. That is inside lower arm, sleeve. Now, drag it much closer so I can see what I'm working with here. I'm going to actually use the hole I made in it as a way to insert it. So fasten. The screw hole we made on that side versus the screw hole we made on this side. And if that looks right, we can say OK. So now we've made a little sleeve for the pencil to ride in and out of. Oops. It looks like we lost an assembly mate doing something. That's weird that it did that. Oh, I'm still inside of mate. Cancel. Wonder why. Oh, something broke over here. If you're not careful, sometimes things will break. It's that tangent mate that's throwing everything off. Let's do it. All right. Sometimes you'll find your mates get lost. Let's go back and fix that. All right. Now let's try one more time. So there we go. So now we've got a little sleeve we can 3D print. A pencil you're just going to glue or rubber band or whatever to your gear, so that when your robot can basically, you can have it right and bring this up by controlling this servo and then turn it on and bring it down into your page and move your arm around as it writes. That's one way you could modify your robot to do something. The trick is when you want to modify things, bring them in, use your various mates to get parts where you want, and then modify your parts in context to remove the pieces you want to remove. I know the demo was a little bit ugly, but it kind of gives you the idea of what you can do. I'm going to stop recording now. What questions do you guys have?